By now, you should be very familiar with the histogram tool, the first tool that we discussed together. And we knew how to make use of, for example, the collected data about the thickness, how to identify the classes, how to calculate the frequencies, and then how to uh, draw the histogram, and then how to interpret the histogram. Uh, However, in some cases, you want to have a quick way of collecting the data and doing the analysis at the same time. Not collecting the data and then at a later stage you will analyze it on an Excel sheet or in a piece of paper. But you want to calculate or collect the data and um, um, do the analysis at the same time in real time. And especially if you wish to do it in the shop floor where you may not have access to many technologies, and you would like, for example, your operator to do this collection and analysis at the same time and act accordingly. Here the check sheets come into play, and they play a very good role in having this quick way of collecting and analyzing data at the same time, so that your actions will be coming very quickly accordingly as you collect the data.
Check sheets are very helpful in many situations, including when we would like to show the production process distribution so that we know how our process is performing, similar to the case in which we were checking the distribution of the thickness of our products in the 100 samples. And also it can help with identifying the number of defects in different categories, such as, for example, this example, we have surface scars, cracks, incomplete, misshapen, and so on and so forth. It would be easy to use the check sheets using these tallies in order to identify what is the distribution of each of the causes or issues. Utilizing check sheets can make it easy to understand and analyze our performance in a more effective way than the histograms. How so? Because in check sheets, once the data collection is complete, the distribution becomes accessible. We don't need another step to draw a distribution. So when we use the check sheets over various intervals, that allow us to do effective comparison. You can use distinct colors for separate data origins. For example, if you're collecting the defects or a specific phenomena in your process, but you're gathering the data from different origins, such as different machines or different workers, you can make use of the colors to distinguish between the different machines and different workers, so that you can do further analysis later and you can have better clarity on the difference in performance later on. Also, it is crucial to examine the form of the distribution and ensure it aligns with the specified limitations, similar to what we already did in the histogram. So the analysis can be very similar to the histogram, but the beauty of this tool is that you can do it using just a blank sheet of paper. It can be used without any kind of technology, on the spot, on the shop floor itself. Let's see this example in which we are trying to see the distribution of specific defects in a production line. So we have those 5 types of defects, and as we go throughout the our shift, for example, we identify and calculate just the frequency of each of the errors, and without doing a further analysis, we can know directly that the incomplete is the one that is more contributing to the overall issues that we have with our products. So, for example, this check sheet allows us to identify the types of defects and their percentages, and makes it very easy to identify the factor that contributes the most to our defects. We will not have a specific template for this because it varies from a situation to another. But the idea here is that you design a table that is relevant to your problem, put it in a piece of paper, and then use it on the spot. So you can have your own template that you can use in your factory or in your company, and then use them on the spot to track your performance, such as the types of issues, the measurements, and also to evaluate the performance for different KPIs.